All right, my friends. So welcome back to another SHSAT practice test. This is 2024 Test B. Overall, this is a pretty good test. I think it's pretty fair. A little heavy on the scale drawings, but we don't see really any of that consumer math that kind of bogs us down on some of these practice tests. So overall, I'd say this is a pretty fair test. There's definitely some interesting stuff near the end that we don't typically see as much. You guys kind of know my speech. There shouldn't be any horrible computations. If we're doing something terrible that's taking us a long time, we obviously miss the point of the question. And that's especially true of this test. Pretty much everything here should be pretty quick mental math. Really no standard algorithm required. So with that, let's jump right to it. So the first one says that if there were 1,000 vehicles sold, how many of them would be two doors? So we go right after it with the number of two doors out of the total. And we say, well, if there's 2250 out of 9,000, and what would that be out of 1,000? So obviously we're going to divide by 9. A quick check of my divisibility rule for 9. If I add the digits of 2250, they add up to 9. That proves it will be divisible evenly by 9. And if I do divide it by 9, I get 250. And that's pretty much it, right? We can also say, if we were astute enough to realize that this is actually equal to 1/4, then we can just take 1/4 of 1,000, which is going to be 250. 59, one of the many aforementioned scale drawing questions. So they're giving us a little extraneous information, which we actually see a few of on this test. It says if the width of something is 9 inches and 2 inches represents 3 yards, how many yards would that be? So if we want to set up a proportion inches to yards, we take the scale, and that would be my proportion. So we can either cross multiply, get 2x equals 27, and x is going to be half of 27, which is 13.5. We could think about the multiplier here, which is 4.5. We could multiply 3 times 4.5. So 3 groups of 4 is 12, half of 3 is 1.5, so that gets us 13.5 that way also. We can find the unit rate, sort of. We can say 1 inch is 1.5 yards, and then we can multiply this by 9. And 9 times 1.5 is 9, plus half of 9, which is 4.5, and all roads here lead to 13.5. 60, and this is one where you just got to be familiar with this type of question. Everyone's getting an equal number of items. This is a GCF question. So we want to know the GCF of 60, 72, and 84. So usually a good strategy for questions like this is the GCF can't be greater than the difference of any pair of numbers. So the difference of 60 and 72 is 12. So that should be our max. Right now we're going to realize that 12 works if we try 12. We can also say, let's say we didn't identify 12, right? Hopefully we know these are all divisible by 6. So if I divide everything by 6, I get this. And now I say, wait, I can divide these all by 2. And now I don't have anything in common from 5, 6, and 7. So they were divisible by 6 and 2. 6 times 2 is 12. So that's a pretty easy way to do it. All right, we always see a question like this, usually on the short response. We want 5% simple interest, right? So we should be able to take 10%. So 10% of 900 is going to be 90, which means 5% is going to be 45. Now we want $360. So we want to know 360 divide 45. Well, hopefully we know 360 divided by 90 is 4. 45 is half of 90. 4 times 2 is 8. Or we can just do the division as is, but we want to find a good way of doing 5% of 900 that's not converting it to a decimal and multiplying. So usually I would use a benchmark, either say that, hey, well, what's 1%? Well, we should know that 1% of 900, right, is just going to be 9. That means 5% is going to be 5 times 9. All right, 62, I really like this question. I kind of wish we saw more things like this. So there's a lot that we have to know here and a lot that we have to do. One is that I want to simplify these numbers, right? So I realize that 49 I can divide by 7, and I can divide by 7 again. And now my numerator is 3 times 2 times x. My denominator is 48. So if I divide my numerator and denominator by 3 times 2, which is 6, that just gives me 1. This gives me 8. So now I'm looking at x divided by 8. Now, hopefully we know a thing or two about eighths. So we should know some common fraction decimal equivalents, eighths being one of them, right? So if we know 1/8, we should know 3/8, meaning I triple this. We should know 5/8, which means I multiply it by 5. And we should certainly know that this is equal to 7/8. So if we know that, x is 7, right? And it works out to be pretty easy. But there was a lot we needed to know here. We needed to be able to simplify that expression. We certainly should not be doing any multiplication, right? We talked about this before, right? Whenever you solve a proportion, you should always be able to simplify it to the point where it can't be simplified anymore. And that's what we did there. All right, 63 is an approximation point. First thing I do, I say, oh, I don't want to do this. So I look at my choices and say, great, I've got 2 negative numbers and 2 positive numbers that are not at all close together. So really all I need to do is approximate. This is 3. Let's call this 2, even though it's a little bit bigger or smaller. And then this is negative 4.5. Well, it's 3 minus 2 is 1, plus 4.5 is about 5.5, but I actually was kind of light with my rounding, so it's going to round up to C. None of the answer choices are even close, right? We really should not have been doing any computations there. All right, 64 is a little too soon for the same question, right? So we got centimeters and kilometers, and it says 2 centimeters represent 3 kilometers. So I could see some people getting confused with this because you actually can convert since they're both metric units, right? But this is what they want us to do. And it says to the nearest kilometer. All right, so, I mean, I'm just going to cross multiply, right? So I get 2x is equal to 13.5. So x is going to be equal to 6 3/4, which is going to be closest to g, right? I mean, really, those choices also aren't terribly close together, right? So like if I took the 2/3 and I double it, it would mean that 4 centimeters is going to be 6 kilometers. So 4.5 centimeters is a little bit more than 6 kilometers, so the only one that makes sense is G. Literal equation here, this one should be very easy. Make sure we can do basic literal equations, right? They shouldn't involve factoring or anything like that, but solve for x in terms of y. So we're going to isolate the x variable, and then of course we'll divide by 2. So we get y minus 4 halves. All right, the next one. So they give us a little bit of extraneous information there. They just want to know the difference between the times. So the difference between the times is 74 hundredths minus 69 hundredths, which is going to be 5 hundredths, right? And anyone that knows me, or if you're one of my students, you know that I don't say point because if we say the place value, it gives us the fraction. So this is a good example of that. 5 hundredths literally converts into 5 out of 100. Which is going to be 1 out of 20. All right, now my one gripe about this and many of the tests is I don't know why they are so obsessed with box and whisker plots. They're very useless in real life, but you got to make sure that we're prepared. So none of the students scored 100 points, right? So it looks like this one scored 100 points. So we're just going to kind of take each piece of information and whittle some stuff away. All right, so that's been used. I'm going to use the last one because that's easy. The lowest score was 54. All right, so this one does not have a lowest score. That's 54 to me. Okay, we get rid of this one. 75%. Now, each part, right, of my box and whisker, whatever it looks like, each part is 25%. So this is like 0 to 25%. And then this is like 25 to 50%, and 50 to 75, and 75 to 100. So each one of these, that's why we call it quartiles, right? Each one of them is a quarter. So 75% scored less than 82. So just going back to my green one here, I would expect to be this to be the score 82, because that would mean 25% plus another 25% plus another 25%. That's the 75% below. So if I look at my 2 graphs, I want to see which one has the third quartile of 82. Well, they try to trick us here by giving us a max of 82. That's no good. We want the one where the third quartile is 82, so we're going to pick choice B. So that one was a little bit tricky because they gave us the max instead of the quartile. 68, if I add, again, going back to my don't say point, say place value, this is 13 hundredths. So n is equal to 13 hundredths plus 207 hundredths, which to me is 220 hundredths, which is then 22 tenths, which is then 11 fifths. So again, the values of not saying point are already kind of paying dividends here. For the next one, this one's pretty easy. It says we have 12 sides. It says one side is 20, the whole perimeter is 100. One side's 25, another side's 35. So I've already got 60 out of my 100. Right? So the other 10 sides are equal, and they have a perimeter of 40. So we do 40 divided by 10 equal sides is 4 each. Guys, as always, if I'm going too fast, just stop and pause the video. I just try to do this kind of quickly so it's not a 2-hour video. Number 70, this one is just attention to detail and reading. So we realize that there's 17 cards right now, which doesn't mean a whole lot because she's taking out some cards. She takes out a yellow card. She takes out a green card, right? So now we're down to 15 cards. What's the probability of a green card? Well, she took out one of the 4 green cards, so there's only 3 of them left. That should be a 5th. 71. So we've seen questions like this that are way more complicated, right? I think one of the tests was similar setup. What was the difference between the 10th number and the 6th number or something like that, right? This one's easy, right? 3 more than twice the number that came before it. So 93 is 3 more than twice the number that came before it. So 90 equals 2n, so we can probably figure out that n is equal to 45. And I guess if you had to, you can use the choices, but I mean, it's really just a 2-step equation. All right, another one of these questions. Somebody got a little lazy. And the rest of this test is pretty good, but I mean, they're even giving us the same conversion factor. I mean, just different units. The numbers are the same. 2 inches is 3 miles, 5.4. So this was 5 4/10. Apologies. So this one's got some decimals. So I should still be able to multiply, right? Now, I mean, we realize that choices E and F are out. They're too small, right? We can probably figure out that this is times 2 7/10. So this will be times 2 7/10. So 3 times 27 is 81, so 8 1/10. 73 is based on the fact that we should know a wheel is a circle, which is 360 degrees. If there's 15 spokes that are equally spaced, we're going to divide that by 15. Now, it may help us we should know this, right? So, if we know that, let's do this a few different ways, right? I should hopefully know 360 divided by 30 is 12, right? And 15 is half of that. So there should be twice as many of these. So it should be 24. Or I can take this fraction, right? And I can say, hey, I want my denominator to have a 0. I'm going to create an equivalent fraction by doubling. And now what do I have? Well, I have this, and then I have this. So either way, we're doing 360 divided by 15. We just want to try to avoid using standard algorithm. So we can either simplify by doubling, like I did, or unsimplifying, or we can do what I did up over here, and we can say, well, I can divide by a friendlier number that's a multiple of that, and then figure it out. All right, this one should be pretty easy. If t is equal to 1, m is 72. If t is equal to 2, m is 36. If t is equal to 3, m is 24. And I'm going to add these together, and I get 132. 75. Listen, if you really want, right? So the best way to do this is obviously to find the area of the whole thing, right? So 8 times 16, we could do 8 times 10 and 8 times 6. I like to break this down into 16 being 8 times 2. So 8 times 8 is 64, times 2 is 128. If we really want to be fancy, we can express 16 as 2 to the 4th, and 8 is 2 to the 3rd, which means this would be 2 to the 7th. So a lot of different ways we can do just the basic multiplication. But really, we should be doing the area of the whole thing minus the unshaded piece, right? And the unshaded piece is 1/2 times the base times the height. So the whole thing is 128, right? We don't want this 32. So in case you can't see that, that's where I got that from the 4 that was there. And if we subtract that, we're going to get 96. Now, if you wanted to, you can think about making this 2 and making this 2 and using trapezoids, right? So just to get some practice with trapezoids, right? Area of a trapezoid is 1/2 times the height times the sum of the bases. So if you wanted to be really fancy, we could say, well, this trapezoid has a height of 16, right? Because the bases are the parallel sides. And the bases, if this is 8 and this is 4 and 4, would be 2 plus 4. So 2 plus 4 is 6, 1/2 of 6 is 3, times 16 is 48. So that would make this 48. That would make this also 48. So if you want it to be difficult, I just put this up there so we get a little practice with area of a trapezoid, because we haven't seen this on too many tests, but it does sometimes show up, so we want to be prepared. So it would look like that. But the easiest way is just a rectangle minus the unshaded triangle. So this one says we have equal amounts of both types of juice. Great. So I'm going to say, well, one batch of juice is 5. So 250 divided by 5 is 50. So I must have 50 of each, because 50 times 2 plus 50 times 3 is 250. So that one was pretty easy. It should just be 50. All right, consecutive integers, right? We don't want to do this the way we do it in school with x plus 1, x plus 2. We want to think about the fact that the mean will be equal to the median. So I'm going to take my 110 and divide it by 5, and that will always give me my middle number. Now, if there were something like 30 numbers, then there's other strategies we take after, but I'm just going to drop this in here. All right, so I can very easily see that those are going to be my numbers, and then the least of them is this number here, which is 20. All right, 78. So m and n are positive numbers. How many of the 5 expressions will be mn? So you could make them numbers, right? You can use 2 and 3 or 5 and 7 or whatever you want. But let's just think about which of these are going to be positive. So answer choice 1 is going to be negative. Negative m times negative n, negative times negative is positive. This is an absolute value, so it's positive. This is an absolute value, so it's positive. This is an absolute value, so it's positive. Right? So the 3 absolute values and the product of the 2 negatives will all be positive. The first is the only one that will be negative. Oh, my favorite, another box and whisker plot. So let's see. I'm going to take my minimum, which is 3.5, and I'm going to realize that this one does not have a minimum of 3.5. All right, we got rid of 1. The maximums in all of them are the same. So now we're going to find the median. So I'm going to say, well, this is my 1, 2, 3 smallest, and then this is my 4th smallest, which means I've got my 1, 2, 3, 4 largest. So my median is going to be between these two, which is 4 and 7/10. So hopefully we can do this as it is. So this is not a median of 4 and 7/10. This is not a median of 4 and 7/10. Thank goodness we did not have to do any more terrible work with a terrible box and whisker plot. Next one's nice and easy. If I add up all the numbers that are here, I get 32, which means there's 18 peaches. Hopefully we know that 18 out of 50, if I double it, is going to give me 36 out of 100, which is 36%. All right, let's pay attention to this one, right? It says we have 9 equal cubes. Each one has a side length of 4. All right, so the volume of a cube, right? It's a rectangular prism where all the side lengths are the same, so it's side cubed. And I have 9 of them. So I have 4 cubed, right? That's one of my cubes 9 times. So I have 64 times 9. So using my ones-digit strategy, 9 times 4 is 36. My number should end in 6. I could multiply it out if I wanted to, but my ones-digit strategy is pretty foolproof. All right, 82 was kind of an odd one. It says its population had decreased, so the average population per square mile was 1,500. So 1,500 people per square mile times 50 square miles is 5 times 15, and then my 3 zeros. All right, well, that was pretty reasonable. So if we went from 84,000 to 75,000, we lost 9,000. Oh, great, another box and whisker plot. Well, this one's easy. The interquartile range is the size of the box. So it's the difference between the upper quartile, which it looks like is 27, and the lower quartile, which is 6. And I believe that's it for box and whisker plots, thankfully. 84 is probably the most challenging one on here, because this requires a lot of kind of prerequisite work. So it says L is a list of 25 consecutive integers. Fine. Now it says the median of set n. All right. How am I going to find the median of this number set? Well, we know that if I take the extremes, their average will always be the same, right? 6 plus 22 divided by 2 is going to be 14, and so is 7 plus 21 divided by 2, which means my middle number is going to be 14, because if I keep repeating this process, there's 25 numbers, there's going to be one number in the middle, that's number 14. So that's the smallest integer in this other set. So set L is 25 integers starting with 14. Now what's my biggest number? Well, my biggest number means I'm going to have to add 24 to this. Not that I need this number because I don't what's my median going to be here? Well, there's a few different ways I can do this. I can do the exact same thing, where I take these numbers and I add them, and I divide it by 2. I can also say that if there's 25 numbers, right, which number will be the median? Well, 25 plus 1 is 26 divided by 2 is the 13th number, because the 13th number will have 12 numbers less and 12 numbers greater. So if this is my first number, then my 13th number will be this number plus 12. That's going to be 26. So there's a lot of different ways that we can find the median. Really, the best way is usually to take the first and the last and take the average. But there's a lot that we have to do there. That was not an easy question after a bunch of easy questions. This is an easy question. So the ratio question we see a little bit later is more challenging. This one's pretty easy because x to y is 1 to 2. Now, normally what they would do is they'd say y to z is 7 to 5 or 3 to 8 or something else, but they're giving us 2 to 5. So I don't need to rewrite the ratio, which we will have to do later. Now, it says the sum is actually 40. Well, if I look at this right now, the sum is 1 plus 2 plus 5 is 8. Well, that means all these numbers need to be multiplied by 5. So really, it's going to be 5 to 10 to 25, and the value of y is going to be 10. All right, so this is one where you need to have a little experience. Now, one thing we can do is we can look at the choices and we can say, 3 of the choices are multiples of 4, which maybe we'd expect the answer to be, and one of them is not. We'd say, okay. And if we want to do it algebraically, we could say, well, if this is one of my first number, right, then I'm going to get 4x plus 6. So the sum of these numbers is going to be 6 more than a multiple of 4, meaning it's not going to be a multiple of 4, right? Because 4 more than a multiple of 4 would be another multiple of 4. So this should be an even number that's not a multiple of 4. Well, to me, that seems like it should be choice F. Now, what I also could do is I can take a bunch of consecutive numbers that are negative. Now, what happens if I add these numbers? Sure enough, I get negative 10. So there's our proof. All right, 87 is one that kind of tries to trick you, right? So there's 12 different values here. So I'm going to say, I got to find the median. Oh, man, there's an even number of numbers. So what does that mean? Well, the median is going to be between the 6th and the 7th. So I'm going to say, well, how do I find that? Well, let's see. If I start from the top, I've got 5 numbers here. That means this is the 6th number and the 7th number. Well, I don't have to do anything because I don't have to add the same number to itself twice and take the average. Let's say we want to go the other way. I need the 6th and the 7th. Well, this is the first 4, and this is the next one. So this is the first 5 numbers, meaning this again will be the 6th and the 7th, so we don't actually have to do any math there. All right, this is another one that I thought was very unusual. Good question, though. Some of these questions, I got to say, are actually pretty good for some of the stuff we've seen so far, at least. So what's 10 divided by x? Well, let's see. I'm going to approach this as a math teacher, and then I'm going to approach it not as a math teacher. So I'm going to say, well, if I divide, I have xy equals 30. Right, so I want a denominator of x. So I'm going to divide both sides by x. So I get y is equal to 30 divided by x. And I'm going to say, well, how can I get 10 divided by x? I could take a third of both sides. So on the left side, I get a third of y, and here I get a third of 30, which is 10, divided by x. All right, so that's done as a math teacher, right? Usually when I'm doing questions like this, I try to put myself in, my 7th or 8th grade self's shoes and say, well, I probably wouldn't do that, right, honestly. So I'm going to say, well, let me solve for x. Well, we all should be able to solve for x by dividing by y and get x is equal to 30 divided by y. And now I'm going to say, well, what would 10 divided by x be? Well, it would be 10 divided by 30 out of y. And even my 8th grade self knew how to divide fractions, right? I knew how to multiply by the reciprocal. And that would give me 10y out of 30, which is y thirds. So that's definitely doable. Not that the first one was terrible, but, this is an unusual question. It wasn't terribly difficult, but unusual, but definitely something we should be able to do. All right, this one should be easy. All right, so PQ is 3 minus 1 1/3, which is 2 2/3. And QR is 2 1/6. Sorry, this is 1 2/3. So we're going to subtract 2 1/6 minus 1 2/3. So really it's 2 1/6 minus 1 4/6, which is going to be 3/6, which is half, right? That's just a computation. I don't have to do too much there. All right, this one's a little more challenging, right? So it says W to X is 70% of WY. So W to the Y is the whole thing. So W to X is 70% of the whole thing. That means this is 70%, which is 7 parts, and this is 30%, which is 3 parts. So really I should use a variable, right, like 7a and 3a, but I'm just going to represent that as the number of parts. Now it says the distance from X to Y is 15 miles. All right, that should give us a pretty straight proportion then. I realize that I'm multiplying by 5. 7 times 5 is 35. So that's really all we had to do there. Number 91, we're using the counting principle. There's 3 ways from W to X. From X to get to Y, there's 4 ways. So from W to X to Y, there's 3 times 4. And then 3 ways here. So we just multiply to get 36. This is the ratio question I was alluding to earlier, right? People to dogs to cats. So it says the ratio of people to dogs is 4 to 1, and the ratio of dogs to cats is 3 to 2. All right. So what we want to do is rewrite this ratio, right, in terms of this being 3. Now I don't really need to do this again, but I need to come from here to here. I need to say, well, if there's 4 people for every 1 dog, if there's 3 dogs, then I would be multiplying that ratio by 3. So a 4 to 1 ratio is 12 to 3 to 2. This is what I call my master ratio in terms of integers. Could I have cut this down to 1 by using fractions? Yeah, I can divide by 3. Kind of an unusual way of doing it. All right, so what I did here is a lot easier. Now we want people to cats. Well, people is 12, cats is 2, so 12 to 2 is the same as 6 to 1. So it turns out to be pretty easy. 93 also turns out to be pretty easy. It says side length of square S is shorter than t by 1. The area of S is 9. All right, so if the area of S, like the side squared, is 9, then the side is going to be 3. And it says the side of S is 1 shorter than t, so t has a side length of 4. So the area is 4 squared, which is 16. So we want to know the difference between 16 and 9, which is just going to be 7. So that's a pretty easy one. Okay, 94 this is kind of like a 7th grade state test question nowadays. So when we distribute the negative, we get negative a half, we get plus 9 halves. So really what I have is half x minus x, so I've got negative half x, and I've got 7 plus 9 halves, which is going to be, if we want to do this in terms of halves, 7 is 14 halves, so that's going to be 23 halves. All right, so we realize we need the x to be negative, so these are going to be out. And we also need the constant to be positive. So with g, if I distribute the negative to 23, I get negative 23 halves. So we know h is going to be the only one that works. 94 should be pretty easy, right? 1 out of x, if I need to make it have a denominator of 2, I multiply by 2. And now I've got this. Subtract the numerator, keep the denominator, nice and easy. Okay, 96. It says there were 10, 5, 1, and 4,984. Great. So there's 5,000 people in total. And 16 of them did really well. We want to know what percent that is. Well, we could use scale to some extent, right? In other words, 50 divided by 5,000 is going to be 1%. 16 is about a third of 50, a little bit less. So we'd expect about a third of a percent. That looks like G to me. Now, if we want it to be a little bit more precise, we can make this out of 100. So I need to divide the denominator and the numerator by 50. So my numerator would actually be 16/50ths out of 100. Well, what's 16/50ths? Well, 16/50ths is 32 out of 100. What's 32 out of 100? 32 hundredths. So really, if I wanted to rewrite this fraction, which I'll do down here, it looks like this. And we know that a part out of 100 is a percent. So if this was 1 out of 100, it would be 1%. If it's 0.32 or 32 hundredths out of 100, it's going to be choice G. So again, probably easiest thing to do is what I did in red. just go by scale, right? 50 out of 5,000 would be 1%. This is about a third of that, so that checks out as G. But if we want to do it exactly, we would do what I did here in orange, and that also is G. All right, we don't see this too much on practice tests, but we see it a lot proctoring the real test. Complementary, supplementary. So we need to know complementary angles have a sum of 90, supplementary sum of 180. So it says the measure of B is 3 times the measure of A. So one thing we can do is we can do this, and we can say x plus 3x is 4x equals 90. So x is going to be 22.5. So 3x is going to be 3 of those, which is 67.5. We can also say that since they're in a 3-to-1 ratio, angle B will be 3/4 of the 90 degrees. And that's going to get us the same thing, right? Since it's 3 times as much, it's going to be 3/4 of the entire angle. So 3/4 of 90 is 67.5. All right, this is a really unusual one. The wording is very subtle, right? So it says the height in 2013 is 300% of. Now there's 300% more, which would be 4 times as much, and 300% of, which is 3 times as much. Very subtle. So what I'm going to do is I'm going to say, well, let's call the original height 1. Well, the height in 2013 is 300% of 1, which is 3. Again, if it said 300% greater, that would be 3 times as much, that would be 4. So the language here is very subtle, but it's very important. Now, language is still subtle. By what percent did its height increase? Well, percent of change is amount of change divided by original. So the amount of change from 1 to 3 is 2. The original amount is 1, and that's going to be 200%. So I can make a case for picking 100%, 300%, very subtle with the language here. But that's exactly the process, and that's how we go about it. 99 says a gallon is 16 cups, and each cup is 8 ounces. Now, if you want to be really savvy here, 16 is 2 to the 4th. 8 is 2 to the 3rd. That's 2 to the 7th. If you want to be not savvy, you just multiply it out, and you get 128. And you count off. Well, 2 to the 6th is 64. 2 to the 7th is 128. Okay, this is an unusual one, but it's actually pretty easy. It says a square puzzle has an area of 64. Okay, so if the area is 64, then the side length is going to be 8. And now it says a cube has a volume. Now, volume of a cube, we said before, is the side cubed. So if the volume is 64, then the side length is 4, because 4 cubed is 64. What's the ratio of the puzzle? This is the puzzle to the block, which is this. So 8 to 4 is 2 to 1. So just be careful, right? F and H are very similar. It's just the order that's different. So we want the side of the puzzle, which is 8, to the block, which is 4. This one is really unusual. So it says, in a certain class, she will take 4 tests. Okay. She's already taken 2 of them and got these scores. Okay, so she has 164 points. Now it says what's the least score she can get on the 3rd test and still be able to finish with an 85. So she wants an average of 85 for 4 tests, right? So she wants 340 points. Now, what is the least she can get now? Well, the assumption then, I guess, is that on the 4th test she's going to get 100. Right? So she wants to basically do as bad as she can and still leave herself the possibility to get 100 and to get her 340 points. So if she has 164, and if she can get 100 on that test, she'll have 264 points. Right? Meaning the bare minimum she has to get now is 76. Because if she's got 164, which she definitely does, and she adds that to 76, right, that's going to give her 240. Now she goes into that 4th test and she is still able to get that average because she's able potentially, because it says this, that she can get 100. So I don't love this question. It's a little bit unusual and the wording is a little vague, but that's what they wanted you to do. All right, this one's a little odd too. Good question. Definitely makes you think. So it says the first pizza is cut into 18 slices and they eat 11 of them. So now this other family has slices that are size of 15. And they're eating X of them, and they don't want to eat more than this other family. So this is going to be my inequality. How many pieces out of 15 can you eat where it's not going to be greater than 11 out of 18? I'm going to say, well, what can I do with this? Well, one thing I can do is I can make a common denominator. So if I want to put this out of 180, this would be 110, and this would be 12x. And I want 12x then to be less than 110. So if x is 10, 12x is 120, that's greater. If x is 9, this works. Okay, not really my favorite way of doing it, but that works. Now what else can we do? Well, we can kind of cross multiply, right? I generally never teach my students to cross multiply in a proportion, in an inequality. But if we want to do it, we just have to bring our cross products up and across. So what that means is if I do 15 times 11, the 165 goes over here on the left, and the 18x goes over here. So we have a similar sort of setup, right? If x is 10, 180 is going to be not going to be less, 180 is going to be greater. And if x is equal to 9, then the right side is going to be 162, which is less than 165. All right, we can also just try some numbers and see what works. So 6 will work, 7 will work, 8 will work, and 9 will also work. 10 won't work. We can also multiply both sides by 18 and that, by 180, and that'll clear the fractions, and that will actually just give us this exact inequality if we do that. Okay, 103, we've got 0 to the third, which is 0. We've got 4 to the 0, which is 1. We've got 2 to the negative first, which is 1 divided by 2 to the first, which is half. And we have negative 1 squared, which is 1, so that's going to give us 2.5. This is another kind of unusual one. So it says we have a tree diagram. So this is showing that somebody picked the number. It says you pick a number and then get rid of it, and then pick a different number, get rid of it. So like this path is showing someone picked a 1, and then they picked the 2, and then they picked the 3. This is showing you're picking the 1, and then the 2, and then the 4. Well, the only thing that's left then is the 3. All right? So that's going to be choice G. All right, 105 is kind of a 7th grade state question about unit rate. So it says the temperature went from 4 2/10 to negative 7/10. So it obviously fell by 4 9/10. And that was 3.5 hours. So I don't usually use decimals, but since there's a common factor here, we can divide by 7. And I get negative 7/5, which is negative 1 4/10. So that was pretty straightforward. Here we just need to know that there's 3 feet in 1 yard, so 20 yards by 14 yards by 6 feet, which is 2 yards, is going to give us 560. All right, 107. This one we have to be careful with, right? So it says, student made a list of all the possible products of 2 different numbers. All right, so how many different combinations? Well, we got to make sure we're careful, because we can either say 10 or 20. I can do 3 and 4, 3 and 5, 3 and 6, 3 and 7. I can do 4 and 5, 4 and 6, 4 and 7. I can do 5 and 6, 5 and 7, or I can do 6 and 7. Now, the place we run into trouble is if we use slots. We say, all right, how many choices do I have for my first number? We say 5. How many choices do I have for my second number? 4. So we say I have 20 different combinations. Yeah, but I'm double counting all of them, right? I have 5 choices, so I can pick 3 and then 5, or 5 and then 3. So really, there's going to be 10 total combinations, right? Just like I listed in red. Now, how many of them will have an odd product? Well, the only way we get an odd product is by multiplying odd numbers. So I can have 3 and a 5, I can have 3 and a 7, or I can have 5 and a 7. All right, so out of my 10 combinations, there's only going to be 3 of them where both numbers are odd. All right, 108 is also kind of an odd one. It says the number n is divided by 25. We get a quotient of 10, and then a remainder of 5. Okay, so my number must have been 255. That's not so bad. What would happen if we divided by 25 as a decimal? Okay, well, that would be 10 and 5 25ths, which would be 10 and a fifth, which would be 10 and 2/10. Which is kind of an unusual question, just not really that hard. All right, 109 it says we have these equilateral triangle, and then we've got these circles. So we have to know, of course, that circumference is pi times diameter. So each diameter is 2. So this is 2. So the circumference of each of these circles is 2 pi, except obviously this is half a circle. So half of that is going to be 1 pi. So if each of these pieces is 1 pi, then obviously 3 of them would be 3 pi. Okay, 110. It says he's placing a card in a bag and replacing it. So probability with replacement. He wants to get the number 5 every time. So he's got the numbers 1 through 5. So I reach in. My probability is a fifth. I put it back. My probability is a fifth. I put it back. You can see how this goes. All right, 1 out of 125. All right, number 111, we want to convert 10 meters per second into feet per hour. So 10 meters in 1 second. Okay. Now, how many seconds are in an hour? Well, it's going to be 10 meters in every second times 60 seconds in a minute times 60 minutes in an hour. So that's how many meters per minute. Now we need to convert meters into feet. So we're going to divide by 3/10. So what am I doing? Well, I'm doing this and I'm doing this. So I've got this, right? Because if there's 36,000 meters per minute and there's about 3 meters per foot, right? Really 3 1/3. I'm really multiplying. I'm dividing both sides by 3/10. I'm dividing 36,000 by 3/10, which is what we did here. And if I don't want to deal with the decimal, I'm going to multiply the numerator and denominator by 10, which is 360,000 divided by 3, which is going to be 120,000. All right, 112, another really unusual one. We don't see too much on here with repeating decimals. It's kind of like a lost art, converting repeating decimals into fractions. Now, we don't really have to do it here, because what we realize is the repeating pieces will just subtract. Now, they're not going to completely divide out. Now, why does this work? Well, think about what we're really doing, right? Right? What would happen here? Well, all of these 3, 4, 1, 2s, they're going to keep subtracting. 2, 2, 2, 2, 2, right? You see how this goes. So it's going to be 2.22. This is my answer. Now, how do I convert that? Well, again, that's kind of a lost art. And if you know how to do it, you make an equation. You make x equal to the repeating part, 10x equal to the next part, and subtract. We don't need to get that deep into it, but we do need to know our ninths. So if we know 1/9 is 0.1 repeating, that means we know that 2/9 is 0.2 repeating. So this is 2 and 2/9, which is going to be equal to 20/9. So that was hard. You had to know a lot there. You had to know to subtract the repeating parts and that they will become a repeating part, not that it's just 2.22 and then it stops, which I think is a choice. And then beyond that, we have to actually go back and know that 1/9 is 0.1 repeating, so 2/9 is 0.2 repeating, and then we need to convert it back into a fraction. All right, so this is another one where we're taking the area of the whole thing, which is 3 by 5, and taking away the stuff we don't want, right? So this is a triangle, a right triangle, that's going to be 4 by 3. So 1/2 of 4 times 3 is half of 12, so we're going to have to get rid of 6. Right here, I've got a 5 by 2, so half of 5 times 2 is half of 10, so I'm getting rid of 5, so collectively I'm getting rid of 11. I end up with 4. And then this is an interesting one too. So we want to know how many more white marbles we can add to make the probability 3/5. So if we're just doing this just straight on its own, right, by the book, we're going to say, well, right now there's 16, 14, and 10. There's 40 marbles. And there's 16 of them that are white. Now, I'm going to add a whole bunch of white marbles, right? I'm going to add X white marbles. So I'm going to end up with 16 plus X white marbles and 40 plus X total marbles, and I want that to be 3/5. I don't really think this is the best way to do it. I'm going to be very honest. So we think about the other side of this. The probability of white is going to be 3/5. Well, what that really means is not white is 1 minus 3/5, which is 2/5. So I'm going to say, well, I've got 24 not white. Now those 24 not white marbles are not changing. I'm not getting more of them, I'm not getting less of them. So if I want X to represent the total here, right, here X is representing the number of white. Here, maybe I should use a different variable, I'll use Y. That's going to represent my total marbles. Now obviously we should be able to multiply this, and we get Y is 60. Well, that should make sense, right? Because again, if the probability of white is 3/5, then not white is the other 2/5. So those 24 not white marbles should represent 2/5 in my total. So there should be 60 total marbles. Well, right now there's 40 total. So what would happen if I added 20 white marbles? Well, now there's going to be 20 plus 16, or 36 white marbles out of 60. And of course, we divide by 12, and we get 3/5. Could I solve this equation? Yeah, if you want to cross multiply and deal with variables on both sides, we can do that. But sometimes we want to think about the number of not, in this case, not white, but not preferred marbles. All right, guys, I hope that was actually pretty quick considering. So I hope we learned something new today. Questions, comments, you can always post, and I'm happy to answer your questions. If you like the video, like, subscribe. Hopefully we got more SHSAT videos and other Algebra 1 videos coming soon. Thanks.